Now let's take our Lewis dot structure skills to the next level. Here we have a polyatomic ion, and the first thing we're going to do is draw our skeletal structure. We have one nitrogen, so that is going to be our central atom. It's also the more metallic because it's larger than oxygen. Okay, so that's our first step. Now the second step is to count all of our electrons. If we look at our periodic table, we see that nitrogen has 5 valence electrons. We see that oxygen has 6, and I have 3, not 1 oxygen. And I have a negative charge, which means I have to add 1. So I have 5 electrons, 18 electrons, and 1 electron. So that's a total of 24 electrons. Okay, now I'm going to distribute these 24. Oh, wait, I've got to see how many I used here. All right, I have 2, 4, 6. I use 6. Okay, I have 18 electrons left to distribute among my atoms to make sure my octet rule is fulfilled or all atoms are happy. So we're going to do our outer atoms first. Each oxygen has 2. Each oxygen needs 6. And I have used all 18, but when I go back to check, even though my oxygens are happy, my nitrogen only has 6. So here we have an instance where I don't have enough electrons to keep everyone happy by distributing them as lone pairs. Because if I took a lone pair here and put it here, then my oxygen would be deficient. So what we're going to do is we're going to do a double bond. I'm going to take these, doesn't matter which 2 electrons we take, but this one's closest to where my pointer is, so I'm going to take these 2 electrons and I'm going to share them between the nitrogen and the oxygen. So I have a new structure where this lone pair here is now going to be shared. My other oxygens remain the same, and when I do that, everyone is now happy. Now this doesn't follow the typical rule for nitrogen. Nitrogen typically has 3 bonds and 1 lone pair, but it is what works. And oxygen does follow the rule. Well, it doesn't really follow. It follows the rule here and doesn't really follow the rule here. Oxygen typically has 2 bonds and 2 lone pairs. So this is a little outside of the box, but it works in terms of where the electrons are, and this is the correct Lewis dot structure. So go ahead and pause this slide and see if you can figure out the Lewis dot structures for these 6 different molecules or polyatomic ions. Okay, so let's look at this first example here. Now this one is a little bit tricky. Your rules say to put the most metallic in the center, and it's hard to see which one is going to be, well, chlorine should be the more metallic, but it's really not the one that's in the center. So in a situation like this, where it's not really clear, I would tell you what the central atom is. So in this case, nitrogen is actually the central atom, and there's no way, I don't think, based on the rules, that you would necessarily know that. So I would tell you that. Now let's look at how many valence electrons we have to work with. Nitrogen has 5, chlorine has 7, and oxygen has 6. So that gives us a total of 18 electrons. And then this is actually the structure. Let's see. So once you know that nitrogen goes in the middle, then the rest is pretty straightforward. There is going to be a double bond, and how would you know that? Well, between oxygen and chlorine, oxygen is going to be happier with the double bond than chlorine is, because chlorine as a halogen really does prefer to have a single bond. So I would tell you that nitrogen was the central atom, but you would have to know that oxygen prefers the double bond rather than the halogen. Okay, now these two right here are similar in that they are oxyacids. How would you know that they're an acid? Well, they begin with H, and they're an oxyacid because they have oxygen in them, and they're not binary. So in oxyacids, we're going to have our central atom as the single atom, and then our hydrogens are going to be attached to different oxygens. So let's look at this one first. If we look at how many valence electrons we have to work with, we have 3 from hydrogen, we have 3 from boron, and we have 3 times 6 or 18 from oxygen, so a total of 24. Our skeletal structure is going to have, let's see if I can get, there we go. Our skeletal structure is going to have our central atom connected to the oxygens, and then each oxygen is going to be connected to a hydrogen. Once we do that, 2, 4, 6, 8, 10, 12, we use 12 electrons in the covalent bonds, or the connection between these atoms, and so we have 12 more to work with. 2, 4, 6, 8, 10, 12. The remaining 12 are distributed as lone pairs. Now remember, boron is an exception to the octet rule, so it doesn't have 8 electrons around it, and hydrogen is an exception to the octet rule, so it doesn't have 8 electrons, it only has 2. Oxygen is not an exception, so it has 8. So boron has 6, hydrogen has 2, oxygen has 8. Everyone's happy, and oxygen is doing what oxygen typically does, 2 lone pairs and 2 bonds. Now let's look at our other oxyacid, because it's going to be similar in structure to this oxyacid. We're going to do our skeletal structure, phosphorus attached to 4 oxygens, and then 3 of the oxygens are going to be bonded to hydrogens. Okay, so here we go. Here's the structure right here. 1, 2, 3, 4, and then 3 of the oxygens are bonded to hydrogen. And it doesn't matter how these hydrogens are attached. I usually just write them in 180 degrees. But we have 32 electrons total. We have 3 from our hydrogen, 5 from our phosphorus, and 4 times 6, 24 from our oxygen, to give us a total of 32. When we count what we used in our bonds, 2, 4, 6, 8, 10, 12, is that right? 2, 4, 6, 8, 10, 12, 14. What we have left we distribute as lone pairs among our oxygens. So everyone's happy. This oxygen has only 1 bond and the rest are lone pairs, which is not typical for oxygen, but it can happen, and everyone's happy. Oxygen and phosphorus have fulfilled the octet rule, and hydrogen just has 2. Okay, now let's look at our polyatomic ion. Nitrite has a total of 18 electrons. Nitrogen is going to be in the center, and we don't have enough to distribute lone pairs to everyone, so we have to have 1 double bond, and it doesn't matter if your double bond is on the left or on the right. Here's our other polyatomic ion, sulfite. There are enough electrons to distribute as lone pairs, so after we connect our oxygens to our sulfur, we have 20 electrons left to work with, and we distribute those as lone pairs. Now this one was kind of hard, and to do this you had to remember that molecules tend to be symmetric and that hydrogens could only have 1 bond. So the way to make this symmetric is to have 2 hydrogens on each phosphorus, and when we connect our phosphorus to one another, we have 4 electrons left over after we subtract what we've used in bonding from our total 14 electrons, and we distribute those as lone pairs. So hopefully you're on the right track, and if not, you're learning the tricks of the trade for Lewis dot structures.